And today we're presenting the first session from introductory talk series that we called Beam Learning Month. And this month of May, on each Wednesday, we will be presenting talks and hope that these talks will provide you learning experience with Apache Beam and help users to get onboarded to the project in more interactive way. So today's presenters are Sam and Ning. They're software engineers from Google Cloud, and they will be showing how to prototype a Beam pipeline using publicly available data and using Jupyter Notebooks. They will have chance to introduce themselves more, but I wanted to remind you that this is the first session, and don't forget to sign up for the next upcoming sessions. So next week, we will have a session that will take take you today from prototyping your Beam pipeline to building a production-ready pipeline. And the week after that, Ismail, one of the PMC members for Apache Beam, he will actually show you how to run your pipeline on top of Spark. And the week after that, Max will show you how to do the same tricks on top of Flink. So don't forget to sign up. And if you don't see links currently, just follow the same platform where the one that you used to sign up for today's session. And yeah, we'll post links there. And as Bill mentioned, you will have a chance to ask questions from the speakers at the end of the presentation. Just share your questions, and yeah, speakers will answer them at the end. And I will be sharing the links to the presentations and video recordings both in social media and on Apache Beam's YouTube channel. And on the final note, I would love to hear your feedback about today's talks and its format and content. And this is the first time we're introducing these types of sessions. And if you see anything that you think we could improve for the next ones, just let me know by filling out this survey. And the survey will also help us, like me and the speakers, to understand your familiarity with Apache Beam and help us to curate the content for the next ones. So let us know what kind of sessions you would like to see in future. Like, do you want to have more beginner workshops? Do you want live debugging sessions? Or do you want to see more examples of use cases? And yeah, and just let us know, and we'll try to accommodate your wishes. And yeah, that's it for me, and I will let Sam and Ning take over the speakers panel.
Thanks, Jamal. That was a great introduction. My name is Sam, and I'm part of the Google Cloud team. I've been working at Google for the past about 5 years, and I've been working in earnest in Apache Beam for maybe the past year.
Hi, I'm Ning. I'm also a member from the Google Cloud Dataflow team. I've been working Beam and Active Notebook for the past year.
Okay, great. So let's kind of jump into here. So the format of today's presentation is that we just have a quick little 5-10 minute introduction to what Apache Beam is, and kind of the execution model and the data model to get you primed for the interactive demo that we're going to do after. Can you all see this? Yes, awesome, thank you. All right, so I know that some of you are new to the Apache Beam. So what is Apache Beam? And Apache Beam is simply an open source unified model for defining both batch and streaming data parallel processing pipelines. pipelines. It's a little bit of a mouthful, but we can break down this into its component pieces. So what does it mean for Apache Beam to be a unified model? In this context, unified model simply means that when you're doing batch processing, when you have a bounded amount of data that you're going to transform and then load somewhere, or a streaming pipeline where you have an unbounded amount of data, such as live data, Apache Beam shares the same API for both batch and streaming. What does it mean for it to be data parallel? That just means that you can have a large amount of data, and then we can arbitrarily cut that out into separate pieces and parallelize each separate piece into different workers, different VMs, able to parallelize almost indefinitely. Processing pipelines, it just means in this context, workflows for extracting data from a source and storing it with maybe some optional transformation. But really, Apache Beam is more than just a data processing model, right? Apache Beam is an abstraction layer. And this abstraction layer allows you, the user, to not only utilize a single runner. So if you already have a Spark workflow that you're working with, you can use Apache Beam model to rewrite that, and then you can run it using any other supported execution backend for Apache Beam. So Apache Beam can take advantage of Spark, Flink, Dataflow, Apex, and other runners too. And depending on the execution backend, you can also run it locally or in the cloud. So Apache Beam is this really awesome tool that allows you to abstract away all the execution details where you can write your business code using the Apache Beam SDK. I think we have 2 officially supported languages, Java and Python. Go is up and coming. I think it's in beta right now. So, and we also have a Scala wrapper around our Java API. What is Beam used for? So like I said beforehand, some general use cases are ETL, logs analysis, event-driven processing. What we've seen in the past, more concretely, are ad engagement metrics. I think Twitter was doing something for that. Revenue forecasting, usage pattern analysis, and platform for SaaS. So we've seen Apache Beam being used in a dynamic way where TensorFlow was generating these graphs underneath using Apache Beam for machine learning. So how does it compare with Spark, Flink? Kind of like I said before, Apache Beam is a lot different than Flink and Spark in that it's an abstraction layer, right? Flink, you can only really do streaming processing. Batch is kind of a special case of streaming. Apache Spark can do batch, can do streaming, but you have to use slightly different APIs for both. Apache Beam kind of tries to unify this across which execution backend you're using, language, and whether or not you're doing batch or streaming. So this next part is to kind of get your mind ready for the interactive experience. Ning and I are going to be writing some live code, and I want you to have this model of what the code is kind of doing in the background. So Apache Beam has 3 primitives. It has a pipeline, which is just a directed acyclic graph of p-transforms. And a p-transform is just a way of reading some data, writing some data, optionally transforming the data in the middle. And the p-collection is simply an immutable, potentially distributed data. So when you're applying these p-transforms, what you're doing is that you're reading from that p-collection and you're appending it to this global view of this pipeline you're creating by appending these p-collections. So now what is Beam's data model? Beam's data model is that you have these p-collections, which are immutable, potentially distributed. And what that means when you're executing is that you can take this p-collection and you can assign it to different key and window ranges. keys are self-explanatory. Windows are kind of these time-based ranges, so they have a start and they have an end point, and a P collection can appear in multiple different windows. So if you have a window that is like a 10-second fixed window every 10 seconds, then a P collection can potentially appear in each one of these windows. Now, what is inside of a window? Inside of a window are just bundles. Bundle is kind of like a unit of kind of execution for the P transforms that I talked about earlier. And what's in a bundle? A bundle is just kind of these data elements that's all a part of this P collection. All right. Kind of as a quick summary, we're creating this DAG. This DAG has P transforms, which read a P collection, write a P collection. P collections are simply some immutable data that you have. All right, and now it's time for the live coding section. Ning is going to show you how to set up the interactive Apache Beam experience. And then after that, we are going to be showing you how to read data from some COVID tracking site. And then we're going to be doing some transformations on that. And then lastly, we're going to be diving into how to utilize the Apache Beam in streaming mode.
Okay, I'll start sharing my screen. Can you see my screen?
Yeah, we can see it.
Does it contain a terminal inside of it?
Yep, we can see the terminal.
Yeah, so first we want to set up a local Jupyter Lab and install Apache Beam from the source code from head. There is a page on GitHub where you can figure out how to do the setup. So I just go through it. I've already created a demo virtual environment here, and I've already activated it. What we want to do is we want to install some dependencies so that we can start a local Jupyter Lab instance. First, we can do it. We can do a pip install Jupyter Lab. And this will install Jupyter Lab with all its dependencies. And then we can, I've already cloned a Beam here, so we can start installing Beam from source code. So there's one thing to note is that when you install Beam from source code, you need some extra dependencies such as gRPC tools and MyPy protobuf. If you do install from the PyP, you don't need those dependencies. So you can do this. But for this demo, we want to install it from the head. Now we are under the SDKs Python directory. You can say pip install -e and dot install. So first we need to install these two dependencies so that we can generate the protos. So the first thing is called gRPC tools. And there's another one called MyPy protobuf. Then do pip install -e dot to install the Apache Beam SDK. So for this demo, we are going to use some interactive Beam interactive notebook features. So we will also install some extra dependency after this. So we can also say pip install e dot. So I'm in Z shell, so I need a backslash to escape this. Thing called interactive. If you put it like this, we can actually install all the dependencies necessary for interactive Beam, so that we can have some visualization features. We run the Beam code in a notebook environment. There are some other dependencies where you can install, such as interactive Beam test, and GCP if you want to use Google Cloud features. So we probably don't them, but we just install them anyway. The next thing we want to do is we want to add a kernel to the Jupyter. To do that, actually go here. We already have IPy kernel installed. What you need to do is to do Python -m IPy kernel, install user, and give a name of the virtual environment, and you can give a display name so that you can use it. So say name is demo, give it display name as demo. Let me copy paste the link here. Okay, link is in the chat. Okay, to verify if we have the kernel installed, we can say kernel spec list, Jupyter kernel spec list, and it give you a list of available kernels. So we can see we have a demo kernel now. Okay, and the next thing we want to do is find a directory where you can start the lab from that directory. Let's say lab. Now we have a Jupyter Lab instance started locally. So you want to pick the with the kernel we just created. We give it a name demo here. So we click here. Now we have a Jupyter Lab instance installed and started with all the Apache dependencies we want to use. You can also use hosted notebooks on Google Cloud. It's a similar experience instead that you don't need to install anything. You just click a link and you're here. The next thing we want to do is we want to do some live coding in Apache Beam batch mode to deal with some COVID tracking data. So we go to the covidtracking.com API, and we see that there are several endpoints we can get data from. So we want to play with the JSON data and CSV data from the site. So if you directly read JSON, it can be loaded into memory as structured data. But if you download the file, you have to read it and do some handling. So we will demonstrate both of them. So let's copy the link. Let's give them some names. So if it's JSON, current, give this one, and it's CSV, current, we gave it a different name. Copy link address here. Let's make it bigger. Okay. So we want to define some utility functions to get the data. We say get JSON data from a UIO. That is like a we need some import. Say import JSON and import request. We can copy the code into the new cell and execute the code as we go. So let's just create a session. In Jupyter Lab, if you click tab key, we'll do some object completion for you. Here we already executed the import cell, so we can do the object completion very easily. So we want to get the data into JSON. Let's say JSON load. And here's the session to get the data. Data will be in text. Okay. And then we can return the data. Let's see that works. We say return the data equals get JSON data from the JSON current UIO. And let's see what current data is. So it's a JSON formatted data. Looks like it has a lot of fields in it, and it doesn't seem that all the fields are the same for each data point. And we can do something similar for the files. You can actually clear output to save some space. You also delete the cell. If you want to view the doc string, you can say tap Shift Tab, and it will show you the doc string of the functions you're using. So let's define another utility function to download the CSV file. And give it a file name. So do a similar thing. And let's open the file. The file name and write it as bytes. To write. So what we want to do is to get the data from the URL, get the file, get the content from file, and this function is just to return the file name. Okay, let's see if we can get the file current. Okay, download CSV from the CSV current. Give it name current. Okay, this is being executed. We see there is a current file coming up. Oh, let's give it an extension name. Oh, that's better. Let's delete this file. Okay, now we see we have downloaded the current status, the COVID tracking cases data CSV file. Take a look at the data. Some of the fields are empty, some of the data are missing. But basically, if we use the CSV file, it's already structured in a unified format, except some of the fields are missing. So we can just use that. So now we can start writing some pipeline to process the data. Let's say import Apache Beam. Okay, and also we will need a interactive runner. Okay, let's see what else. Beam has been modular form. Okay, I guess we need to clean up some of the protobuf files. Just let's see. Then, do you remember where the proto files are generated?
Yeah, go to the Beam root directory.
The root directory.
Yeah, and then just do a /gradle w.
Gradle
colon SDKs. Colon Python colon build.
You failed. I think all we need to do is to clean the protos. See if I can figure out. Is this proto the same thing? Run API PB2 looks like here. Wait. Do you know where the PB2 files are? We find maybe just restart again.
Why don't you try and do pip install
from the head, from pip IP?
Yeah, pip install -e .gcp test. I think that should get the protos.
Okay. See if we can import Apache Beam. we can import it now.
Cool.
See if I can put the thing we need. Oh, great. Okay, so now it's generating up-to-date portals, I guess. Yeah, that's a risk to take when you install from the head. It's possible that you are having some corrupted files in the system. Okay, let's see. So we run all this. We still get the current CSV file. Okay, we can keep going. So we can create a pipeline. Let's see if this doesn't have any problems. Giving it a runner called interactive runner. Oh, sorry. Okay. Now we've created a pipeline. It will be an Apache Beam pipeline object. So this is a primitive pipeline. We can start creating transforms against the data. Let's say we already have the current data. We can do something with it. Say create a current data P collection from a memory JSON object. We can do this by applying a transform. We can name a transform by giving a string name like this. Say create P collection from JSON. And to create some P collection from in-memory data, you can say Beam create, and then we can give it the current data we got from JSON here. You can say Beam create current data. Then we got a P collection called current data from JSON. Since this is a immutable distributed data, if you want to see what's inside of it, it's different from the normal approach when you do things in the code in a local machine or in a single machine. So we've introduced something called interactive Beam. Let's say from Apache Beam runners interactive import. There is a module called interactive Beam. Let me give it a short name here called IB. So we can say IB show current data from JSON. It will give you a data table view of what the data looks like. So you can see, let me make it smaller. You can see this is a data table where you can do search, you can do sorting, it's paginated, all this kind of stuff. And that way you will be sure that you are actually getting a P collection associated to the correct data. We can also do clear output here, save some space. Okay, the other way is to create a P collection from the file. Let's say we do current data from files. Say, you can give it a name, void create P collection files, and a basic transform is beam.io read from text. With this transform, you can actually supply a file name to it. We already got a file name here called current CSV. And then you can also skip headlines. Since it's a CSV file, the first line is header, we skip the first line. By doing this, you're actually creating a P collection by reading the contents from the file. You also do the same thing, IP show current data from files. Since we're reading from the file, it's actually not structured. So we'll just demonstrate how you can create a structured data from reading things from files. Because it's very common when you do batch, you read a lot of files into the system. So what we can do is, let's just do, we can first import the CSV things, because when we look at the data, we actually see that some of the data contains comma inside of it. We don't want to just do a split. It will give you incorrect columns. We use CSV reader. We can do read headers by providing a CSV file to it. And let's open the file. Read mode file. We can do the header line by read line and script all the things. And then we can return the header by calling the next thing from the reader and reading this header line as if it's a file. Let's see if we can do CSV file current. We get the headers, and let's see what the header looks like. Okay, basically the headers we want. And next thing is we can create structured data from the pre-collection. So all these things are worked the way we name tuple. So we can do from collections, import name tuple. Just define a type called USConveyed data, and create it from name tuple by giving it this exact name, and supply the headers we just read. And then we can define a do form. That's another basic things in Beam. So see beam.do form. In each do form, there is a function called process. We will have to override that process function, and the logic inside of it is basically applied to each element in the key collection. So first, we want to pass a schema into it. Schema will be the name, the tuple we just defined. And then we override the process function in a do form. So basically, the arguments are self and element. The element, basically, you can see them as basic units inside a P collection. And this logic inside of the process is applied to each element. You don't need to worry about how they are executed for each element. You just know that this logic will be applied to each element. So we can say we use the same reader, just pulled it from the CSV, and for each element it will be a line of the file. We read it, and then we get all the columns from it. And then for each value, we want to preserve the whether it's a digit or it's a string, a non-digit. So we want to just do some similar things. So since all the numbers are cases, I think they are integers, we can just use int value. The value is digit. Else we give it back. And let's just say values. And then we can return. So in the process, when you return, you could either return, you should be returning an iterable. You could either create a list here or do yield. So we just return self.schema using all these values to create the name tuple. Let's see if that works. So let's say the current data would be current data from files. We apply a So now we are actually appending transforms to some peak collections. This peak collection was created by appending a transform to the empty pipeline we created initially. So you can see it's a graph breaked. So we can call this step parse by doing, so since we here define a do form, we're going to use that do form to create a transform. So there's something called pardo. With pardo, you actually give it a do form you define, and then it will apply the do form logic to all the elements associated to that peak collection and run it in a distributed way. So that's the advantage of Beam. You don't need to worry about the runtime. So we can see US copy data CSV reader and passing the schema as US copy data. Should get some current data. Let's see if the data is already structured. Okay, using 29 already, right? Required position and positive. Seems some of the data is missing. Oh, okay. Sorry. Here we just provided an array. We should pack the value and provide it to schema. Okay, let's do it again. Okay, now we have all the 32 fields instead of one array. Okay, great. If you look at the data, basically the same thing here, similar to the JSON. It's just now is structuring this way, and we basically unparsed it from the file. So let me see what we. Oh, okay, yeah, and actually, the interactive module also provide a collect function where you can, if you don't want to use it directly inside the Beam scope, you can actually collect it into a pandas data frame, and then you can do it locally in your local machine without running it distributedly. Okay, and there is another interesting thing we have here. So if you give it current data, you can actually provide a option called visualize data. That field is set to true. We do IB show. Besides this frame, this data table, you actually get two facades visualization. We had this for like, it was originally designed for machine learning, but we think it is a general good way to visualize data. The way you can do is like you can do label by, let's say, positive. It will show you all the positive numbers of each data point, and then you can do binning by positive. And actually change the number here of the binning, and you can see how the data distributed. You can also do scatter plot. Say if you want to find the relationship between the correlation between the positive and maybe pending. You can see all the data are visualized here. The same with most positive is state of New York and all the things. And then with less positive, but a lot of pending cases, the state is Florida. And then you can see some general statistic of the files, of the data points. You can also plot them in log axis and expand this. It's just pretty an interesting way to explore the data. So now we see we can use the visualization to get some conclusions. Say the most positive number is for New York State. Let's see, since not all the data are like small enough that we can visualize them, this interactive Beam tool is actually for you to explore in a known small set of data where you prototype your pipeline, and then you can put it in production with production data set where you cannot do the simple visualization. And once you verify the correctness of your pipeline, you can run it against a very large data set to get the same result. So let's say if I cannot visualize this, the data is too big, I have to run it distributively, and I want to get the result that New York State has the most positive. What should I do? The thing is, like, now we want to do some aggregation against the data. Basically, we want to find the maximum number, but these data are like an M tuple. They cannot be ordered directly, and we don't want to alter the data points along the way. We can actually create a wrapper around it so that we can sort it. Say from func tools, import total ordering. And say, let's create a class that is a US could be data orderable by quality, where we basically just create a wrapper by passing the data and we define a ordering strategy here. So the greater than is basically self.data positive bigger than other. And then we can create a function to find the positive, biggest positive. This will be the aggregation function we have. And it takes a bunch of values. These values can be empty or another iterable. So we can say 10 max values, if values, else now. We have this function. We can apply the transform. Say if we want to find a max positive P collection, we have the current data. And we can start applying transforms to it. First, we wrap it. Say Beam. There is another thing you use, Beam map. With Beam map, you have only to define a lambda, and then it will process the lambda against all the elements in the P collection, similar to part 2, but this syntax is very simple. Let's see, US copy data, orderable by positive, wrap this data. And then we want to do the ordering, the aggregation. Say find positive Beam dot. Here, this is an aggregation transform where we combine everything globally to with a given function, aggregation function that we define as maximum positive here. This function here. And then we want to get the data out. Let's say unwrap it. Unwrap data. Say orderable data. Orderable data. So if we do IP show max positive, we should be able to see some aggregation. See here, this is New York State. We found it. It has the most positive. Okay, I think I can hand it back to Sam.
Okay, so we only have about 5 minutes left, so I don't think we have quite enough time to get into the streaming example. And so I think we'll just kind of jump into Q&A for the last 5 minutes. I see that there are some great questions on the Q&A panel. So for the first question that I see here, Nate asks, do you just use the interactive runner so you can look at the peak collections in between each transform? Are there other uses for it? And my answer to that is the interactive runner allows for that REPL within the notebook. If you were to use any other runner, you would get some stateful errors. So what's happening in the background is that actually, Ning, can you open back up your notebook?
Yeah.
So what's happening in the background is that when Ning uses that pipe syntax, he is effectively adding the transform. I can't see the notebook anymore.
Can you see it?
No.
No. Let me share it again.
Anyway, he's effectively adding the transform directly to the pipeline graph. And so if you were to execute that, cell with any other runner, you'd be adding that transform to the graph over and over and over again. So with interactive runner, it has some workarounds so that it executes as you'd expect. So the interactive runner really is this kind of environment that allows for this REPL that you see here. Does that answer your question, Nate? Okay. Cool. Thank you. So next question comes from Kaniska. Sorry if I mispronounced your name. How do you implement complex event processing and real-time rule exceptions using the latest Beam? Is Beam plus Flink CEP the only option? I don't personally know about Flink CEP, but with Apache Beam, you do have a lot of control over. So I guess this kind of answers a question later on. So in a do fun, you have control over the execution context in a way. So you can add timers and you can add state between each execution of this do fun. So this do fun is executed for each element in your peak collection. And it's instantiated per element in your peak collection. Actually, sorry, that's wrong. It's instantiated per bundle in your peak collection. So for every new bundle that comes in, it creates a new do fun. So it doesn't carry over state unless you explicitly tell it to. I think that's the only way that you're going to get more complex patterns. Sorry that I don't know about this Flink CEP. The next question is from Nate. What's the difference between using pardo and map? So map is a very simple way of executing a function per element. It doesn't really give you a lot of control over setting timers, which are kind of like a time-based callback, and state, which is how to keep over state between executions or instantiations of this do fun. So map is more of a syntactical sugar. Pardo is a little bit more verbose, but allows you a lot more control. Thomas asks, when do you use the interactive runner versus the local runner? Good question. Interactive runner, you can use it with IPython or Jupyter Notebook or Jupyter Lab. We haven't done much intensive testing outside of that environment. So local runner is when you're doing kind of unit testing or testing with the pipeline. Interactive runner is when you want to use it in a notebook or IPython environment with some sort of REPL, where you can just kind of so
I can add something to this. With interactive runner, you can actually supply an underlying runner into it. So by default, the underlying runner is a local direct runner. You can actually set up your Flink runner locally and then give it to this interactive runner. So if you go to the link of that GitHub page, let me just repeat the link. in the chat. So if you go there, you can actually see you can provide the Flink runner. So this it actually supports this. See, if you say underlying runner, Flink runner, it actually starts a local Flink runner and connect that. So interactive runner is just a wrapper. Yeah, it's a wrapper above the underlying runners. It does everything, kind of appending extra transforms in the backend to materialize data pre-collections into disk so that we can read it later, and to save execution time, and also being able to inspect the data. And also the interactive runner doesn't support all the underlying runner yet. Say if you want to use Google Cloud storage or some other storage, not locally on your disk, we probably need to write out some other wrapper logic so that we can read them out.
Yeah. All right. So I think we're over time, so I'm just going to take these next few questions and leave it at that. Kassav asks, I see the notebook is running in localhost. Does Google Cloud Dataproc run in local machine? I don't know. Sorry. Hemnet asks, in Beam, do you use P collection for data collection and storage? Is it mutable or immutable? So P collection is not using for storage. It's just for data collection. So you read something from a stream, you read something from disk, from a database, you put that in kind of this P collection. A P collection is really more of a logical construct, right? A P collection could live in many different places depending on what's executing it. But it is immutable. A P collection is immutable. Whenever you read from a P collection, and then you do some transform on it, it is creating a new P collection. So P collections are read only. And then the last question, Massey asks, what are the differences between the Java SDK and Python SDK? If I want to do streaming and use the latest features, which SDK should I use? The Java SDK is more up to date. The Python SDK is currently doing some catch up. It recently streaming Python recently went GA earlier this year. So Java SDK is more up to date. But I personally like the Python SDK better. It's less verbose than the Java SDK.
Hi, Samuel. Sorry to interrupt. Can you just take one more question from the YouTube? I see there are a quick question on YouTube. I can just read
sorry,
to you. Yeah.
Yeah, sorry.
So basically they're asking the difference between Airflow and the Apache Beam. He is writing an ML machine learning pipeline. I want to see, which one to choose for their applications. I want to know the difference between Airflow and the Beam.
Did you say TensorFlow?
I'm sorry?
Did you say TensorFlow? Difference between TensorFlow and Apache Beam?
Oh, no. The Airflow.
I don't know that product.
No, the Airflow, Apache Beam and the Airflow.
Oh, Airflow, Apache Beam.
Airflow.
Yeah, I see that the person answered on the YouTube.
Oh, it's already answered?
Yes, and the answer is correct. But yes, Sam, go ahead.
Actually, could you repeat the answer from the YouTube? I don't know much about Airflow.
I think the person said that Airflow is an orchestra and the Beam is more of a complex job creator, complex process.
Cool. All right. I guess we're over time. I'd be happy to stay around and answer questions if people want to, but I think this is about as much time as some people may want to get back to work and other things. Does that sound reasonable?
Yeah, that sounds really Great. Thank you, Sam and Ning, for this demo today, and thanks everyone for joining. And it's great that there's an interest within the community. Like, thank you for asking all these questions. And for the next session, we'll try to get more Beam committers to answer them all. And thank you all for joining, and don't forget to join us again next Wednesday, the same time. And yeah, happy Wednesday, everyone.
Thank you.
Okay, great, thanks. Again, the session is recorded. We're going to share it on the YouTube shortly. And you're also going to receive emails, follow-up emails on some the links to the slides and the other resources. And also for the surveys, for the next session, some feedbacks, some other topics you are interested. So feel free to send to us.
Cool. Thank you. And like I said before, I think I'll scan the chat for a little bit longer. Looks like there's still some questions.
Okay, sounds good.
That's okay. Yeah. All right. So Kaniska asks, is P collection same as a Spark data frame? So it is pretty similar. Well, I guess by Spark data frame, do you mean like an RDD? If that's the case, they are pretty much the same, except that Apache Beam has more metadata associated with the P collection. For example, the P collection has something called a watermark, and a watermark is kind of like a measure of how fresh the data is. To my knowledge, the Spark RDB doesn't have that. The watermark is pretty useful in a streaming context when you're trying to figure out how far behind your streaming pipeline is within the stream. Kiniska asks, is it possible to run tasks of a pipeline from a job scheduler directly, just like Airflow? I guess so. So Beam does have an API where you can, start up your pipeline using some runner. So you can put that into any tool that can, either run Python or run Java or something like that. I'm sorry, but I can't, for some reason, read chat. Chat just comes up as either blanks or some random ASCII or Unicode symbols.
I think it's encoding problem.
Yeah, are you able to see it, Ning? Are there any other questions?
No, I just no. I think the chat probably comes in other language, and when it got decoded from it got decoded into some random character.
I see the chat is fine right now. I don't see any more questions. It's more kind of like thank you for the great talk session presentations. So I don't see much more questions in the chat.
Yeah, okay. Flying Flyers asks, so Beam is a direct competitor with Spark and Flink. I wouldn't necessarily call it a competitor because it's an abstraction layer on top of these different runners, on top of these different execution backends. So you can build an Apache Beam pipeline and you can switch between whatever execution backend you want. You can run, we do have a Spark runner, we do have a Flink runner, we have a Dataflow runner, we have an Apex runner. So it's really trying to get around this problem of lock-in. So I wouldn't say it is a competitor. It's just an abstraction layer that allows you this portability to, kind of, if you find a problem with Spark and you want to run Flink, then you can just kind of move your pipeline really easily onto a new Flink cluster.